data. So I imagine that a lot of you, sorry, I actually can't see my mouse, so I can't cancel this. Got it. Okay, so I imagine that a lot of you are thinking of using some observational data for your analyses. So this kind of observational data may be, I don't know, social media data from before when we still had API access to social media, or news data from different news venues. And this gives us really interesting, so like correlations that we can draw. Okay, so like if we don't do some smart matching or something, we can get these like very interesting correlations. So yes, toxicity increased after the election of Donald Trump. And I mean, this is interesting, but we can't actually get at the causal questions that might be like defining some of these underlying mechanisms. And so these causal questions are really like, if this event didn't happen, would that outcome still have occurred? And I think that one of the interesting ways that a lot of people have been using Mechanical Turk is to start getting at these causal questions. So let's say that we're interested in the effects of news headlines on people's belief that it's misinformation or not. It's difficult to answer these questions if you don't have access to people to show two different headlines to and ask them, which one do you think is more likely to be misinformation? But like Mechanical Turk gives you access to all of these people for a relatively cheap price to be able to go around and say, okay, here are two news headlines, and after you can begin to do A/B tests. And I think that there's a lot of questions that like we can begin to ask this way and like study this way that might not be accessible just through observational data. And then after, like, what Mechanical Turk lets us do is really get to the underlying causal questions that are at play. Again, so like this message distortion and information cascades paper, which we actually used here, we were interested in studying, so like when information propagates on social media, what information is lost? So like, let's imagine that you guys are all read some news article or read some paper. You read a news article that's about some paper, and then that news article already summarized that original paper. And then after you decide to share on Twitter this news article or a summary of this news article, and then your friend decides to share that summary of your summary of this other summary of this news article. And then after some specific information propagates through this network, and you could almost argue that only the essentials are what's boiled and like left over. And to run a study like this is really difficult. And like up to 15 years ago, we would have had to have bring in 20 people to continue writing these summaries, a very specific group of 20 people. So we would have had to probably university bachelor students to do these summaries for this study. But now you have access to like hundreds of thousands of people out there on the internet who can help answer some of these questions that like we're really interested in. So this is one thing that I've also had trouble with. So Akin, as you mentioned, like I feel like a lot of the emphasis of the CSS research right now is on this sexy observational data or social media data. But I think there's a lot of interesting questions that can be answered if you just look at these crowdsourcing platforms to answer them. And you have to be a little bit creative about how you design it all. But like this is kind of my view on crowd work. If I was telling myself this 2 years ago, does that make sense, guys?
Sorry. So it echoes when I speak through my computer, so I have to
run there and back.
So it makes sense for me, but does it make sense for the rest of the crowd? Let me see if I can maybe change the camera and then like allow you to see the class as well.
Yeah, that'd be
like
awesome.
This. Okay. Wave, guys.
Hi.
So I think like none of our speakers in this Summer Institute talked about mTurk and online surveys. Do you have any questions? Because it's a very valuable data source. You don't have to choose between scraping and API. You know, there is There are online surveys that give you a lot of data. MTurk is perhaps the most popular one. Do you have any questions so far about the logic of online surveys, advantages compared to like API and scraping work? It's a very important kind of data source, and many of you are, I think, like getting too much, cornered into API versus scraping debates. There's a third alternative. So yeah, I think you can go ahead.
Okay, great. Awesome, guys. So we use these for all kinds of tasks. So just to reiterate here, OpenAI uses it to model human preferences. We use it to model toxic or non-toxic texts online. We also use it to get like diversity and different opinions. And then after, just to reiterate again, if these crowd workers are actually using large language models, then we risk losing a lot of this human element that we really cared about before. So as I showed before, is like if the actual people who are generating this data are using synthetic sources, then we can have all kinds of problems arise in the models and the opinions that we model. Okay, and so in our study, what we wanted to do was estimate this usage. And so what we did is we ran a previous study. So this actually maybe gives you guys an illustration of like what Mechanical Turk looks like. Is we gave the crowd workers this task. And in this task, we asked them to summarize a 400-word medicine-related abstract. So they were supposed to write a summary and then basically turn it into 100 words. And then we gave them one of 16 different abstracts. This way, we collected 46 summaries from 44 different workers. And now with these 44 summaries, we wanted to see how, if we can somehow detect if ChatGPT is being used in them. Do any of you guys have any ideas for how to detect from the summary text if an LLM built it? There's no wrong answers. Actually, sometimes the most wrong answers are the right answers.
So, any takers of this question?
So just to reiterate, it's like, given a text, how can we know if it was written by an LLM or by a human?
Yes.
Yeah.
If a couple of words are already available in the internet, it can be generated automatically.
No, how can you distinguish between an LLM text and the human organic text? Can you hear, Venya?
Yeah, I can't really hear,
Okay.
so maybe if you could repeat.
Yeah. Can you shout?
The data, all data it's trained from, instead of more diverse, but the created one, it's like a middle of that distribution. Whatever you look at is going for the mean data.
So like, just to, if I heard correctly, the idea would be that the ChatGPT generations would be more like the mean summary. So like you took 1,000 summaries, then you took the average of those 1,000 summaries, and the ChatGPT would look more like that.
Yeah, like they trained the data from the text, and there's 1,000 texts, like 1,000 samples.
Yeah.
So it's distributed on the map. So it can be anywhere, like my sentence. But what ChatGPT creates is for the most common ones of observed
Yeah.
in the database, which I imagine, but that's probably quite wrong.
Yeah, that's actually very similar to what we did, with a little bit of a twist. Before I get into that, I saw one more hand.
Okay. Ali, do you have like?
One thing that I noticed when I was kind of prompted using the ChatGPT was, and also there were some papers for identifying whether the text is coming from whether a human generated wrote that text or not, was they have some pattern. It has it's kind of use some patterns of generation that usually some similar words are coming next to each other. So from the frequency of coming those words from each other, we can understand that it is a human generated thing or not. And the second thing,
Yeah,
kind of one of friend mentioned that. I mean, it's built kind of. I mean, the tool can be built based on this, that whether the text the generated text is kind of aligned with the rank of the Google. Let's say when we are researching a topic on Google, we've got some websites. So whether there is a high similarity between the web pages of those retrieved web pages and the generated text, so we can realize that it is human generated or it's automatic or it is machine generated.
yeah. Those are both really great ideas. The problem is that we don't actually know what ChatGPT was trained on. So like we have no idea what's in there. It's really like a black box. And so like basically, if I could like maybe distill down the 2 points, it's like there's a specific way that ChatGPT talks, and there's a specific way that humans talk. And the ChatGPT texts are like very similar to one another usually. So for example, if you ask it to write a summary for an abstract, it always starts in this paper, the authors do blah, 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 blah. Like every time it starts with that. And so there really is lack of diversity in the summaries that are produced. And while that's bad for us as researchers, because I mean, in the summaries lack diversity, it's really great if we're trying to detect if ChatGPT is present or not. So afterwards, I'll get into how we actually did this like detecting. And it basically relates to what you guys were suggesting. So the idea is that like we give it some real summaries, some real human summaries of these abstracts. Then we ask ChatGPT to write like 1,000 summaries for these abstracts. And then we'll train a model to say, is this sound like a human or does this sound like ChatGPT? And the key to do this is we actually had to rerun a previous study when we had these human responses. And so exactly what we did is we took our abstract, let's call it abstract 1, and we had 2 versions of it, a human version and a generated version. And then afterwards, we trained a classifier. In this case, it's an E5 base model. This doesn't really matter, but it's like this, like we fine-tuned a classifier on Hugging Face, which is like really amazing what the capacities of it. So like, if you guys want to talk more about like fine-tuning a language model for a specific task, I'd love to chat about it. And then afterwards, we took this model that's trained on real and synthetic data. And then after we ran it on the summaries from the new mechanical Turkers. And just quickly, so you guys can like trust me a little bit more, instead of just listening to my words, maybe I'll show you guys the image. This classifier was able to be really, really good at detecting synthetic texts. So we were able to like almost detect all synthetic text, like 97% of them, using this model. So like your guys' intuitions were like absolutely correct, that like ChatGPT really has its own like weird, not diverse writing style that makes it easier to like detect it in the wild. And then afterwards, given this model, now we have a model where like we're given a summary in this paper, authors, blah, 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 blah. And then after we can be able to tell, is it synthetic or is it real? And so what we ended up finding was that between 1/3 and 46% of crowd workers on Mechanical Turk were using ChatGPT. I mean, this is like quite problematic because I mean, like, imagine you're going to the store to buy peanuts. And then after the bag, and you come home and in the bag, you have all kinds of mixed nuts. You'll be pretty mad because you wanted peanuts and now you have a different kinds of nuts in there also. So this is like one analogy that I heard for it. And like, it's true, like we need human data, and human data is going to be more important now than ever. And even the people that we pay to produce the human data for us are using LLMs themselves, and you can't blame them. I mean, if I was to tell you, you either have to do something for 10 minutes by yourself with no ChatGPT, or you can use ChatGPT and get paid the same amount of money in 1 minute, of course you'll use ChatGPT. But still, like, it kind of raises the question of like, how can we make sure that the data that we collect is actually human? So we did some further validation also. So first, what we looked at was basically the keystrokes. So there's a very easy way that you can like basically add keystrokes tracking to these surveys. Ethically speaking, I think it's okay, but this is something we're still waiting for from the IRB. So basically what we found is that whenever somebody typed in the response entirely themselves, it classified all of them as being human. And then after whenever somebody copied and pasted something, then after it was more likely, they classified those as the ones that are synthetic. And then after also extractive summarization is not a problem, because sometimes when people copy and paste, they just take a portion of the original abstract and then they paste it in. Maybe it's some like complicated thing. And we found that when our model predicted, it wasn't usually for extractive summarization. So this kind of leads us to believe that, yes, this model is generalizable to other data sets. We released this tweet a few weeks back, and it got like quite a bit of attention when we shared this paper, which was super crazy for me because I never had a paper that like got media attention. But it's like kind of this like crazy world where you're like reading all the criticisms and all the things that people liked, and it's like a huge waste of time, but it's also a little bit of fun. And one of the tweets that we saw in reply was this idea of like low background steal. So a lot of these like highly specialized measurement devices. So for example, if you're trying to detect radiation, you need a Geiger counter. They need steel to build them. However, they need steel that hasn't been contaminated by radiation. So what people do is they swim to the bottom of the ocean and they find these massive boats that have sunk, which had steel from pre-Hiroshima, so pre-World War II bombings. And then because this steel has lower levels of radiation in them, and then they get that and they sell it for huge, large amounts of money. And the statement was something along the lines of like, now the data pre-release of ChatGPT on the internet will be our low background steel. And so like one way of ensuring that the data that we have is actually human generated is just by looking at, is the date of this being released before December 2022. And so, yeah, there's this whole debate about how can we ensure it. There's some techniques like watermarking that exists. Since I'm telling you guys about the paper, I'll be honest, there are like some limitations with it. So the first one is, I think we paid a little bit low for the summary that we were asking them. We were paying them $1 USD per summary. And the reason we chose this value is this was exactly how much we paid them in 2019. So maybe we could have included inflation, or we could have paid them more money. The second one is we only had 44 responses for this 33 to 46% estimate, and this is not a lot. Also, the type of work is really automatable, so like it's easy to automate this process. But at the end of the day, we were interested in studying humans. And then also, this is a little funny anecdote. We're currently rerunning this study on a couple other platforms. And we've had more than one person summarize the paper by saying, I know what you're doing. I'm not going to summarize this paper for a research article. So now in the future, it becomes a little more difficult to redo these tasks because they're aware of the original paper. And so the next steps for this project are basically, we'll try to run this on more platforms. We'll use different approaches for actually training the classifier, and we'll test out policies that can reduce use. So one of our hypotheses is like, if we just ask the people to not use ChatGPT, probably they won't use ChatGPT. So like, we're going to rigorously try to test all of that out. So this was the first part. So hopefully I introduced a little bit about what crowdsourcing is and the current state of it with large language models. Like this like key data set that we've been using for so long has become a little bit entangled by large language models. And in the second part of this talk, I want to actually ask, like, how well can we use large language models to model linguistic constructs? Like, let's say we want to create a classifier for sarcasm or for happiness. Can we use large language models to help us with this process, which I think is highly relevant for probably a lot of your projects. However, before I get into there, do you guys have any questions about the crowd work, the LLM use there, about the method, or anything at all? Yeah.
I think we can continue.
Okay, awesome. And so in this second part of the talk, I think this is probably the more relevant part of the talk for a lot of you guys. So I'm sure you've seen all of these papers saying ChatGPT can annotate data for you. ChatGPT can create silicon samples. And so in this part of the talk, I want to get into some of this literature and maybe answer the question of like, can you guys benefit from using ChatGPT in some of your group projects? And so the short answer to this question is like, synthetic data is not as good as human data for a lot of tasks, but in some cases it's actually as good. So in this paper was like really a preprint and it's in its early stages, but the idea is how can we generate faithful synthetic data with large language models? And by faithful, what I mean here is synthetic data that looks like human data. And it's like a case study in computational social science. So in the context of CSS, I think there's broadly two areas where large language models are having an impact. On the one hand, large language models are great discriminators. So they're really good at seeing, if you give it a text, is this text happy? Is this text sad? Does this text have a specific hate or toxicity inside of it? LLMs are sufficiently good at detecting this. But then there's also some other research that basically says, actually, large language models can also be used to generate new people for us, basically, and act as silicon samples. So in the annotation space, what a lot of the research has found is that ChatGPT and GPT-4 are sometimes better annotators than actually experts. So what you can do is there's this big paper that I link here, which I'll share afterwards with the paper. And what they do is they go through studies in sociology, like social dynamics, measuring persuasiveness, antisocial behavior, cultural analytics, studies in psychology, to get emotion, humor, politeness, mental health, to see if a text is empathetic or not, positive reframings of it, literature. So can we begin to understand character tropes and relationship dynamics, history, linguistics, political science? And what they do is they go through like 44 or like some 40 number of these different data sets, and they see how well can ChatGPT be used to annotate them. And so specifically what they do is they take an example of a text, an utterance, a conversation, a document, and then after they use this like zero-shot prompt formatting, and they say, which of the following leanings would a political scientist say that the above article has? Liberal, conservative, neutral. Which is another interesting thing that you guys can do in your groups probably is like, let's say you want to understand what are the partisan leanings of a specific document. Does this document have liberal bias or conservative bias? Then what they find is that large language models are quite good at this, so acting as a discriminator. And then the second area where like a lot of research has been going into from the CSS community recently is can LLMs be used to generate data de novo? So like if just like out of the box, can we use these large language models to generate data? And this is one thing that I'm really interested in. So there's some research that says like if we tell a model that it's Republican, it finds that it can vote like a Republican. And there's these companies like Synthetic Users that have formed recently. And so basically think of Mechanical Turk, but with only synthetic people on there. So like now you can go to Mechanical Turk and then you can go to Synthetic Users and have the exact same tasks that we have, but now they have a bunch of LLMs answer the tasks for you. And this is what Synthetic Users is currently doing. However, how faithful is this data and can we make it as faithful as possible? And the part that I'm most excited by is this can like kind of open up a new paradigm for studying linguistic constructs in text. So let's imagine that we want to study sarcasm. Okay, and we want to go through all of the books ever and track how sarcasm has evolved over the years. I mean, how would we even do that? You know, because first of all, language changes. We don't have enough data points labeled sarcasm to be able to train a good classifier. And we want to measure this. So what the idea in the LLM context would be is we would generate a bunch of examples of sarcastic and not sarcastic text using the large language model. Then we'll train a classifier on these synthetic data points. And afterwards, we would run it on the real world data. So one example that I think of here is this one. This is the hedonometer from some folks who've been using Twitter for a little while. And I think it actually stopped with when Elon Musk decided to close off the academic API, sadly. I know Akin has a lot of thoughts on this on Twitter. But this was a really cool project. And what they did is they basically had this classifier to tell you, is a tweet happy or sad? And then they went through the history of all tweets on Twitter or a sample of the tweets on Twitter, and they measured the average happiness and sadness in those tweets. And so what they find is these amazing stories like, okay, Father's Day, it spikes. Supreme Court overturns Roe v. Wade, we drop. Christmas Day, it spikes again. Grammy Awards, it spikes. And then they're able to like basically study how happy is a society in a given moment. However, like what I'd argue is like in this large language model generation, we can build classifiers for anything like this. So again, sarcasm. We could generate a lot of sarcastic text, we use a lot of real examples. And then after we could train a model, and we won't have this, but we can see how sarcastic is a society in a given period of time. And then what this even lets you do is study like subtypes of sarcasm or subtypes of happiness. So like here, since they don't have a lot of data, they trade one classifier that only tells you is it happy or is it sad. But in reality, there's tons of ways that a text can be happy, and there are tons of ways that a text can be sad. And so what if instead of this, we could see different types of happiness? Like, okay, we became more empathetic these months, and we became more joyful these other months. And so we could break it down so it's not only happy or is sad, but we can begin to study a lot of these different types of sarcasm. And so this is what I did in this paper, is we began to look at like how well can we use large language models to basically study sarcasm and sentiment in text. And so what we did is we tried a few different prompting techniques to generate these examples. Then we trained a model both on only real text and only on synthetic texts. And after we compared the performance across these two different tasks. And so we tried a few different prompting strategies. So the first one is we called the simple prompting technique, where we said generate 2 sarcastic texts and after try to ensure diversity in the generated text. And what we found is that just by asking these large language models to generate sarcastic text, they're really, really bad. They start every sentence with, oh, wow, or wow, you're such a genius, or oh, thanks, which is really sad because in the world, that's not how sarcastic texts look like. The other option we thought of was grounding. Why don't we give them real tweets and ask them to rewrite them to make it sarcastic? And then we found that this was a little bit better. And then after finally, we thought, what if we could also ask them to not only rewrite the tweet, but also try different types of sarcasm? So what we did is we created a taxonomy for different types of sarcasm. And afterwards, we asked the model to rewrite specific tweets to make them a specific type of sarcasm. So here's an example of sarcastic mimicry, sarcastic arrogance. And actually, I think this example on the right in all caps is all caps sarcasm. Yes, joined a gym to flex my right to snack because working out and eating healthy is overrated, right? So this was an entirely synthetic example of sarcastic texts. And so as you can see, like as we get down and further down here using these different strategies, they become more faithful, more human-like. Because like if you just ask it to generate 2 sarcastic texts or 10 sarcastic texts, they all sound the same. They're like, wow, you're such a genius. I never would have thought to use a soup to eat my soup. You use a spoon to eat my soup. And there are all these like things that you would never see in the real world. So like if we train a model on them, they probably wouldn't be that helpful. And so what we found, interestingly enough, was that just grounding was the best way to do it. Maybe the taxonomy approach that we had wasn't the best, but we found just by giving a real example of a tweet and then asking it to rewrite it to be sarcastic or not was the best way to do it. And then we did this both for sentiment and for sarcasm. And across both of these categories, we found that grounding was the most important. So grounding in real world makes the best improvement for diversity. Taxonomy generation and grounding does improve results. But still, if we train a model just on real sarcastic text or real happy and sad texts, the original data is far better than synthetic data. So still, even if we try these different prompting techniques out, real data is the best data to train such a classifier. So in conclusion, in this part, if you guys are trying to use ChatGPT to generate data for you guys, then I would recommend that you should ground it in real examples of texts. You should try different prompting techniques, but this grounding seems to be the best one that I found so far. The other thing that's interesting about a lot of this like prompting research is like prompting only gives us a lower bound. So we can, in theory, try 1,000 different prompts, and it becomes super expensive to try them all out. So it's kind of like raises some concerns about the current state of research is like, okay, if we can have a better prompt that does better than this, then like, what's the point of doing this prompt? And it's kind of the problems that we're facing right now. And then after finally, synthetic data doesn't work as well as human data, but we can still get some mileage. And I guess like I will there's this article in the New Yorker that was written back in April saying that ChatGPT is this blurry JPEG of the internet. And so I think this is kind of true that like we can get some good results by training a model on these synthetic texts, but it'll be like a blurry model. It won't be a perfect representation of these texts. So in this talk, I guess like my key takeaways for you guys would be that crowd workers are now using ChatGPT. So I would be careful and thoughtful about how you define your studies. But I think that if you just ask them not to use ChatGPT, you'll be able to get a good mileage from that. Sadly, if we have more and more models being trained on synthetic data, it can lead to model collapse and lack of generalizability to the world at large. So like ChatGPT has very specific ideologies and values present in them that might not be representative of people from the global South, for example, or people with differing beliefs. And so it should raise a huge alarm if like we imagine that now the new models that are being trained on this data are representing only a very specific type of ideology and belief system. LLMs are good at annotating some tasks. So you guys should keep this in mind. So if you're looking to annotate a lot of data, then you can use LLMs for this. And then after finally, synthetically generated data can create sufficiently good classifiers. So let's say that you guys are working on a project and you're like, I really want to study the presence of hateful speech towards a specific group of people, and you can't find the data to create such a classifier. Then you can try to use large language models to generate this data for you to create a scalable classifier, or you can just annotate the data yourselves. And then after finally, I guess this is like my biggest concern of all of this is human text is really important, and we shouldn't get away with ourselves about arguing that LLMs will save the world from everything. So I want to say thank you and happy to take any questions. Yeah, so I guess we'll do this, and then afterwards I have a couple other things to show you quickly.
Yeah, I wish you were here in Istanbul, because right now there's an IEEE conference here on signals processing applications, and there is a sub kind of meeting on computational social science, and this year's challenge is to like create a competition in the signal processing applications on hate speech detection using LLMs in Turkish. So
Wow.
wish you were here. I mean, basically, I don't know who won, but I think like there was a competition, there were papers submitted, and people tried to, you know, find ways to more accurately predict hate speech in Turkish language. And the LLMs were the primary kind of suggested routes.
Yeah. Super cool. Yeah, I think it's so exciting, and they're pretty good at like non-English languages. And yeah, it's a really exciting time.
It is, yeah. I mean, we have people who are working with text here. And when you think of this presentation and basically the application of LLMs in this particular research question, like, did any of you have any changes with regard to the approach you're going to take or the data source you're going to take for those of you who are going to work with text data, text analysis people? Any potential use of LLM you can think of when incorporating into your topic?
Since in our research, we are probably gonna do topic modeling. Maybe we can use these LLMs for kind of common prompts, the way that force or kind of drive the model, let's say ChatGPT, to give us the keywords to be able to classify the, let's say, news data or text data we have, and then see how, and then apply them, probably get their sentiment to see how those sentiments are changing based on the topics in our research. I guess that's pretty useful.
Yeah, actually, topic modeling is a really interesting example. We're currently working on this paper where we're trying to study the sub-narratives of universal basic income in the USA. And one of the things is we need different framings of the issue. And the first thing we tried to do was LDA, which is this like unsupervised topic classification technique that I'm sure you guys might be using or are familiar with. And the problem with this technique is that like, yes, it works really well, but like you have a probability distribution over words afterwards. And then after it's difficult to actually say, okay, the presence of these terms means that it's this topic. And so what we're doing is actually might be interesting for you guys is like you use LDA to get the initial topics. Is like, okay, these are the 10 different words that 10 different most associated phrases in these different categories with this concept. And then afterwards you can ask the LLM to basically annotate the data for you. So you use these topics and you give it a, so what exactly kind of data are you guys using for your project?
Actually, those data will be from newspapers data.
Yeah.
Yeah, this kind of data. I mean, I got your point. You're saying that use LDA to come with the major topics, I guess.
Yeah.
And then use language models to see how it's predicting those topics, right?
Yeah, that's an example. Yeah, but then after if you have too many data points, maybe this gets a little bit confusing, but if you have too many data points, then what you can do is you can basically use ChatGPT to label, let's say, 10,000 news articles. And then you train a classifier on those 10,000 labeled points. This is like, I guess, a little bit, I'm not sure how familiar you guys are with NLP techniques right now, but it's like 4 lines of code, but it sounds pretty complex, where you just like have some representation of the text, and then after you train a classifier on it. And then afterwards, this is another way that you can get like better representation for those topics. But also just LDA by itself is also pretty good technique.
Last question. In newspapers usually, or I mean, let's say in news, usually there are lots of topics being discussed. I mean, let's say they're related. I mean, one country's or one state's ideas or opinions about another countries on some subtopics, and I was thinking that how can we use these models to identify the subtopics per news, let's say per news. For instance, on a high level topic modeling, we say this news is related to, let's say, politics, this news is related to sport. But I was thinking, how can we do subtopic modeling to kind of differentiate the opinions, I mean, in the lower level? So
by subtopic modeling, do you mean that a newspaper article can really be more than one topic? And how can we make sure get more than one topic? Or do you mean by subtopics that if you have a sports article, well, it could be really related to football, basketball, the Olympics, or something else, and getting subtopics for these bigger topics? The second point. Yeah, so for this, what you can do is basically like rinse and repeat. So you first do LDA once to get all of the comments related to sports. And then you run LDA again on that subsample of only newspaper articles related to sports, and then you'll have new topics there. And then you can iteratively, like recursively do this to basically create like a classifier for a specific type of sport, for example. That's like what, yeah. Does that make sense?
Yeah, he said thank you. Yeah,
yeah. Okay.
The sound system in this classroom, we haven't still figured it out, so please bear with us. Any other questions? No, I think we can go ahead.
Yeah, okay, cool. Then the last thing that, like, again, maybe I haven't sold you guys on the value of LLMs. Maybe I have. But I made this quick GitHub repo because I was thinking like, okay, like what's most helpful if I was in this position? Well, I'd probably want some starter code. And since this is all pretty new and stuff, let me just quickly share my screen correctly. Okay, do you guys see my screen over here?
Mm-hmm.
Yeah.
Okay, cool. So if we go here to your, I did this like late last night, so it's not like perfect, but I was like, man, this would be really great if I could share something with you guys. And basically what I did is I created this like synthetic annotations file. And there's like a few goals of this file. Is the first one is to learn LangChain. And so LangChain is really the gold standard right now for using Python to generate data, generate stuff with using LLMs. So there's like a little introduction to LangChain. Then after we'll try to annotate a data set with ChatGPT, and I'll give you guys some like starter code for that. Then after also some code to generate synthetic data for a specific construct of interest. And then after finally, yeah, and I didn't have the time to actually create a classifier on top of that, but if you guys are interested in that, I'm happy to add to this notebook or something, how to train a little language classifier. But I think you guys had in the first 2 weeks some courses on NLP. So this just, you guys will have to let me know. There's one important thing to note is to use OpenAI, you guys do need an API key, but I share the data regardless, so you should be able to go through this. And this API key is free, and they might even give you like $8 or $10 of credits, which is more than enough to use ChatGPT. And basically, we have this sarcasm data set that I was telling you guys about. Here's some like little information. So here's like a sarcastic text and not sarcastic text. And then basically LangChain is this thing, and there's like two important messages that we have. Is one is the system message, the other one is the human message. And so all what you do is basically, and actually in this other file right over here in this utils.py, I have some examples of some of these different prompts that you can use. But all you need to do is basically define a system message prompt, which basically tells the model, okay, you are a model that generates sarcastic or not sarcastic texts. And then afterwards, you define a human message prompt that asks the model to generate this many texts, ensure diversity in the generated texts. And we can do this for annotation and for this. So like the annotation prompt is actually right over here. So you are a model that annotates sarcastic and non-sarcastic text, classify the following text as being sarcastic or non-sarcastic. And then it's really 4 lines of code. You have your example of a text that you want to annotate. Then you have your chat OpenAI key with this function with specific temperature. You should actually probably be using temperature of 0 here. And then afterwards, we take this like prompt template that I share. You just need to change the prompt text there. And afterwards, you can go through and run this chain. So chain.run, and you fill the text, which was this part over here, this input variable, with the example text. And then afterwards, you see that, okay, we have this example text, see people with clear skin feel accomplished, superior, comfortable with their own skin. And then after the model told that it's sarcastic. So this is one way of like getting easily to annotate your data, which again, normally platforms like Mechanical Turk would do. So we can iterate through our entire data set and get all the generations this way. And then afterwards, we can see how well our model performs. Well, with ground truth, we get 60% accuracy and a 50.59 macro F1 for sarcasm. And then afterwards, I run through the same exercise quickly with creating sarcastic text. So again, we use specific prompts, sarcasm grounded prompt, and then after we say, oh yeah, and then the model rewrites tapping a tuning fork and seeing who resonates with, oh yeah, because tapping a tuning fork and seeing who resonates is clearly the pinnacle of intellectual pursuits. And so we can begin to get this. And I just quickly added here some analysis about like, we thought that ChatGPT is not very diverse. And then we look at the presence of the text O in synthetic text and in real text. And we find that 16% of synthetic texts include the sentence oh, or oh, wow, or oh, thank you. Whereas only 2% of the real text include O. So it just goes to show how like misaligned some of the distributions are. I think this has some of the key things. If you guys want to send me an email for any other code you want me to add that might be helpful to you, I think it'll be nice to have a resource like this anyways. Yeah, I know it's coming to the end of your like 4 weeks at SICSS, so I understand some of you guys are probably tired and ready for the papers for the projects. So yeah.
So
Great.
have you sent this, or are you going to send this after?
Yes, I'll send you this and the slides by email
perfect.
or thing.
Perfect.
Or yeah.
One question general, I think like we have some groups that are interested in using LLMs in like diplomatic or international law texts, which are technically supposed to be like more like robotic, more technical. They're trying to make them like non-sarcastic, extremely difficult to misinterpret, right? The nature of diplomatic or legal text is supposed to be like the perfect environment for a ChatGPT kind of thing.
Yeah.
So like, have you ever tried like LLMs on actual like serious text and like not
Like
even
serious texts, like
yeah.
to annotate them or to
I mean,
generate or
do they really perform well on serious text the way we would assume it to be? Because like think about this, like if you have ever been in a room in which an international legal document, a treaty, or like a foreign ministry statement is being written, like it's like a mathematical function. Like they choose words in such a way that it becomes impossible to misinterpret, right? So I would assume that kind of text to be ideally suited for an LLM environment. And I would assume also that like a ChatGPT style, like better trained model would immediately replace any diplomat or any lawyer you can think of. But
interesting.
I was thinking like, have you ever actually tried that in serious context? Like, am I right or am I wrong? Like, do they really
Yeah.
perform well?
Yeah, there's 2 points I'll make here. Another one where I feel like this discussion is being had is in education. So like in education right now, it's like super important that it doesn't hallucinate and like make up facts for people. And I think probably, so there's this like spectrum between creativity and seriousness and like need to be down to the fact. And I think that LLMs probably fall somewhere in the middle. Like, unfortunately, it can be really good at sounding serious, but in reality, there's like a lot of stuff that like it hallucinates inside. And this is why, so I have a friend who's starting a company right now, and it's meant for this like legal consulting with LLMs. And he spoke with a lot of lawyers about this. And lawyers right now don't feel that GPT-4 can replace them by writing the documents entirely, but it can make it really good to do research with them. So now imagine that you have ChatGPT has access to every single legal document ever written. And then you ask the model, which texts relate to this specific part of the paper that we're writing right now? And then afterwards, ChatGPT can find those relevant sections and like tell you exactly what to look at and like begin to summarize them for you. So that's like one way. And the other thing is like from the conversations with like people in the legal field, they suggest that it's a very iterative process. It's like you have one draft, then you get the wrong stuff, and then you iterate on it again. And so like in this like iterative capacities, people are like also really excited for it. But I think like this is a full paper in and of itself, is like to what extent can we use large language model, or like how can we even use them in these serious contexts, which you could argue are probably some of the most important examples of like where they will be. But like the one thing that I like will say is like a high level takeaway is like it's so important that they're grounded in real data. It's like so critical that like you give them something to stand on, because otherwise they're trained on the internet and there's so much spam and noise on the internet, and like it doesn't know that you want it to be like serious here. It'll be like some 4chan legal proceedings or something. So I'm not saying actually, but
like
yeah,
after this talk, go to the like UN webpage and look for like UN statements, like official UN statements.
yeah,
Read a couple of those like official statements, and then go to ChatGPT and tell it to produce a UN statement for you. Like you can't imagine how good it is in producing that
ChatGPT is.
Yeah, mathematical robotic text. Like it produces the best UN statements you can think of. And then
wow.
Like there's a like territorial dispute between this country and this country. Like imagine you're writing a foreign ministry statement from the perspective of country B, like write this, and it writes the perfect foreign ministry statement.
Wow. That is very surprising. No, I guess it's not surprising because it can sound good, but like, is there a lot of substance in what's written?
I mean, is there any substance in actual human statements?
Yeah,
You would say.
That's
Try for yourself. It's very surprising. Like it might change the way you think about LLMs. I mean, the research that you're doing is really fascinating, and I think that's the actual frontier. But I think like we take granted how like good these models perform in actual serious mathematical or like robotic texts. And I would think like a benchmarking study, you could do it. Like it would be a very good idea, you know, how good these models can actually do in their intended setting, right? Serious, factual text, and try that, like, and publish it. Like, do LLMs actually perform in serious settings really well? It would be a good.
Yeah, that's a great idea. Yeah. Yeah, or like find the sweet spot, because I would also imagine that there are some like creative examples where they're like not bad. I mean, like Midjourney or something is also a generative model that's really can be creative in terms of the image that it produces. Like they're amazing. I just signed up for the $10 a month today, and it hurt my bank account a little bit, but it's so much fun. Like that's the most fun I've had for $10 in a long time. Yeah.
Because you were interested in computational international relations, and this would be a very good computational international relations paper.
Yeah, yeah, that's a really, yeah, great idea. Another thing that we're currently looking at is, so like if you imagine diplomacy as being like not a, what's the word? I'm trying to remember my international relations theory lingo now. Like if you're not in a unipolar world where like one person is in charge of everything, but like a multipolar world, is it better? You could like simulate some of this stuff. Like if you have 10 LLMs working together versus you have one LLM working together, when is it better to have 10 versus like, is like, when are 10 minds better than one? So there's this famous like Duncan Watts paper where they found that like individuals are really good at solving simple tasks, but like as you make it more complex, the task, then groups are better. And so like one of our ideas would be like, can we recreate this using LLMs? And if in like 10 years you imagine that some LLMs are going to be guiding our world or something in some like super dystopian future, it's like, would we rather have one LLM that's in charge of it all, or like this like democracy of LLMs?
Good
Yeah.
idea. Do it.
Yeah.
I mean,
Yeah.
good idea.
Yeah.
Okay. Do we have any questions? I'm pretty sure they're going to email you a lot of questions once they start like
Please
running
do.
the code and running into like problems and anything. But like in terms of more theoretical or conceptual, do you have any questions for Venya?
I feel like everybody's getting tired. It's the end of the day. It's a hot Monday here in Switzerland.
No, people start asking questions once they start coding and running into problems.
Yeah, yeah.
Like that application phase is where they start asking
Oh,
questions.
absolutely, absolutely. Yeah.
Yeah. So like turn off your email notifications for a while.
Okay. Okay.
Yeah. Well, Venya, thank you so much. Let's give Venya a round of applause, people.
Thank you, guys. I really enjoyed it.
Thank you so much. It was great to see you.
Yeah.
You like in a physical setting somewhere.
Yeah. See you soon.
Okay. Thank you so
Bye,
much.
guys.
Bye.
Ciao.